The colors of the planets in our solar system tell a vivid story, each hue a reflection of its surface, atmosphere, and cosmic history. Let's dive into this kaleidoscope of worlds, starting with the closest to the Sun. Mercury. Mercury may look like a dull, dark grey rock, but it holds secrets. This planet is scarred by constant meteor impacts, and the fine dust, or regolith, covering its surface gives it that rocky grey tone. Despite being the closest planet to the Sun, Mercury has ice in some of its deep craters that never see sunlight. Moving outward, we encounter Venus. Venus has a yellowish-white appearance. This colour is due to its dense atmosphere, composed of 96.5% carbon dioxide and 3.5% nitrogen. The planet's cloud cover, made primarily of sulfuric acid droplets, contributes to its reflective properties. But here's something cool. Venus rotates on its axis in the opposite direction to most planets, a phenomenon known as retrograde rotation. Our home planet, Earth, appears blue and white from space. The blue colour comes from light, scattering in the atmosphere, and reflection from our oceans, which cover 71% of the planet's surface. The white areas are clouds, composed of water vapour and ice crystals. Earth's atmosphere is 78% nitrogen and 21% oxygen, with 1% other gases. Earth is the only planet not named after a Greek or Roman deity. Its name comes from the Old English and Germanic words for ground. Mars, often called the red planet, has a distinctive reddish-orange colour. This hue is caused by the abundance of iron oxide, or rust, in its surface rocks and soil. Mars has a thin atmosphere of 95% carbon dioxide, 2.7% nitrogen, and 1.6% argon. A cool fact: Mars is home to Olympus Mons, the largest known volcano in the solar system, standing at about 21.9 kilometers, 13.6 miles, high. Jupiter, the largest planet, displays bands of white, red, orange, brown, and yellow. These colours result from various chemicals in its atmosphere, which is primarily composed of hydrogen and helium. White clouds are ammonia crystals, while reds and browns come from organic compounds and sulfur. The Great Red Spot, a persistent storm, is a notable feature of Jupiter's colourful appearance. Saturn has a pale gold colour. Like Jupiter, it's mainly composed of hydrogen and helium. However, an upper haze layer mutes its colours. Saturn's famous rings, primarily made of water ice with some rocky material, appear bright white due to their composition. Saturn is the least dense planet in the solar system. It could float in water if there were a bathtub large enough to hold it. Uranus has a pale blue-green colour. Its atmosphere is 83% hydrogen, 15% helium, and 2.3% methane. The blue-green hue is caused by methane in the upper atmosphere absorbing red light and reflecting blue-green light back to observers. Interesting detail: Uranus rotates on its side, with its axis tilted at about 98 degrees, likely due to a collision with an Earth-sized object early in its history. Neptune appears as a deep blue. Its atmospheric composition is similar to that of Uranus, but Neptune has a more active weather system. The intense blue colour is due to methane absorption of red light, like Uranus, but an unknown atmospheric component and more turbulent atmosphere contribute to its deeper blue shade. Neptune experiences the fastest winds in the solar system, with speeds reaching up to 2,100 km/h, 1,300 miles/hour. And now, for the planet that wasn't, then was, and then wasn't again. Pluto, this plucky cosmic underdog, sports a reddish-brown hue, like a celestial cookie with vanilla swirls. Its colour comes from tholins, fancy organic molecules created when sunlight zaps methane. Fun fact: Pluto has a heart-shaped region called Tombor Regio, a love-you sign to the entire solar system. It's important to note that the colours we've described are generally what would be seen by the human eye from relatively close proximity to each planet. Colour appearances can vary based on observing conditions and imaging techniques.